Hello friends, welcome to Machine Learning, the future course. So in the last part, we have seen the theoretical concept behind the k-means clustering algorithm, and now let's begin machine learning using Python. So I already launched Anaconda wherein I have used Python. So let's copy the data preprocessing template which we have. Before that, let's look at our data set. So what exactly is this data set? So suppose there is a shopping mall and which contains the entries of various members, or as you can say, the members or the customers who are subscribed to their membership card. So clients provide the data such as their age, their monthly income, and their gender, and this is the sheet which has been incorporated from all those details. So various things such as gender, income has been provided by clients, and this spending score has been calculated by a shopping mall person, which has been taking into account various factors such as what is your monthly income, what is the age, how many times does the client visit the shopping malls, etc. So what is our aim? Our aim is to segment their clients into different groups. So that's the clustering problem, because we don't know how many groups we have and we don't know what are the categories we need to divide those clients into. So that's our clustering problem. So as you can see, our area of interest, our column of interest will be monthly income and spending score. So that will be 0 first, second, column number 3, and column number 4, which will be our column of interest, because that's how we can be able to identify the clusters of data, because based on the monthly income and the spending score, we can actually determine what exactly is the cluster or group of data with respect to all those details of those customers. So let's begin. So let's copy the data preprocessing template. Yes, so we have that. Control A, Control C. Yes, so in our new file, we'll actually take this data preprocessing template, and yes, so we'll actually remove this because it's not a data preprocessing problem. Yes, so let's do this. Import numpy, np, pandas, and matplotlib. Yeah, that is the same. Let's set the working directory first of all. So what will be our working directory? So our working directory is labs, machine learning, it will be clustering, and it will be k-means clustering. So that will be our machine learning, our working directory. As you can see, yes, so you have our data.csv as our file. So what will be our x, which is matrix of features? It will be column number everything, which will be the first will be every row, and then it will be column number 3 and 4. So we need to state that. So let's do that. Column number 3 and 4, 3 comma 4 dot values. So let's execute this one by one. So let's execute this set of instructions. Come on, enter. Yes, it's executed. So there is no y here. Yes, so let's execute this set of instructions. So command and control enter. Yes, it's executed. As you can see, yes, we have got our x, which will be your column number 3 and 4 and your entire data set. So we need to actually eliminate all of this because we are not actually looking at all those features, we can actually delete those features. So our next step involves getting the number of clusters which we want to divide our dataset into. So for that there is a method which is called as WCSS, and that method we'll be using over here. So for that, let's first of all let's label it out as computing the number of clusters, and for that we'll be using this method, which actually uses a method known as elbow method. So that is the set of instructions. We'll be using k-means, and then from w for I in the range of the entire data set, we'll be running it k-means plus plus algorithm, random state for actually stating that we have the same results, k-means dot fit, and then we'll actually plot it. So let's plot it. That will be a very interesting graph which will be seen over here. So wait, I think it will be executing some time. So yes, so we have got those graph over here, and as you can see, this is the elbow method, which actually determines with respect to the number of clusters how our WCSS value blows, and what is the criteria for choosing our number of clusters value. The point where actually the change will be very gradually or will be very consistent. So as you can see, from this point to this point, it's a very drastic change. Similarly, from this point to this point, there's a very drastic change. But at this point where number of clusters is equals to 5, after that the change is very consistent, not much very gradually increase or decrease. So it's very consistent change. So this says us that our number of clusters where n is equals to 5. So we'll choose our number of clusters is equals to 5, and our next step involves fitting our model. So applying our k-means to our data set. So let's do that. So for that we'll be using k-means equals k-means. We'll create an object. So n underscore clusters. So what will be the value of clusters over here? It will be 5. Next is init equals k-means plus plus. K-means plus plus. Next is some mistake, yes. Next is your maximum iterations. So these are the some of the argument values which we need to fill for a proper working of your algorithm. N underscore init equals 10, and last is random state. Random state is always equals to 0. So that's it. And as you can see, and in it, so there is 10 number of times it will actually look at the values, and y underscore k-means, which will be our actual predicting value, is equals to, let's fit it. So k-means dot fit and predict. So that will be a fit and predict value, and what will be the input for that? as you can guess is matrix of features, which is our value x. So that's it. So we have actually imported the key means previously, and then we have actually created an object out of it. We have just filled out those number of arguments which we need to fill out, and at last, so the maximum iterations and the n init values are there. So init in the sense, if the happening which you had said in the presentation, that the number of steps involved in it, as you can see over here, the reassignment. So if number of reassignment reaches a certain value, we need to stop that. So that's the value as 10, and after that we have actually used yk means as our predictor value, and we actually fitted and predicted the k means to our data set. So that's it. We need to actually execute this. Yes, it's executed, and at last, so yes, so this is yk means, and let's look at our data set, which is x. So here it is. So customer number 1, which belongs to cluster number 4, second customer belongs to cluster 3. Similarly, as you can go, so number of those clusters have been divided into, customers have been divided into number of clusters, which is total number of clusters are 5. So let's actually plot it out. So to visualizing of k means clustering, so I already defined a template for it, so we'll actually use that template directly to plot it out. So let's copy, let's execute. This is just a template for plotting those points, and here it is. So that's what we have for a clustering algorithm. So the yellow points are the centroids of your data sets. As you can see, cluster number 1 are this, cluster number 2 are the clusters or the data points in blue, cluster 3 in green, cluster 4 in sky blue, and cluster 5 in pink. So this is our clustering algorithm which we have defined over here. So what we have done is just a simple step. So imported libraries, imported a data set. We have actually used an elbow method, wherein we can actually determine the point where the WCS value is not decreasing very rapidly or very gradually. So that point will be n is equals to 5, and the consistency is maintained after that. After that, we need to apply our k means to data set, fit and predict, and then we actually plot those points with respect to this clustering of the groups. So that's our k means clustering algorithm. So hope you're enjoying this video series. All those Python scripts and data sets for each part will be available at my GitHub account. So thank you very much. Hope you're enjoying the video series. Bye bye.